Hi everyone, in this video I'd like to talk about an example with some different forces and see if we can resolve these forces, these tensions on some wires into horizontal and vertical components. So the setup is as follows. I've got two lamp posts or light posts, whatever you want to call them. So the first one here is on the left-hand side, and it's not very tall. It's labeled with 8 units of height. And then over on the right-hand side of my picture, I've got a taller post, and this one is 11 units tall. And what I've done is I've strung some sort of hanging cable or wire from the top of these posts, and I'm going to hang a street lamp, like a traffic light, which is a very bad drawing of a traffic light, but we get the idea. Now, I'm told that the traffic light here hanging from this point is 6. So I can add in some information to my drawing here. If I draw a little horizontal line here, since this height is 6 and the height of this other post here is a total of 8, I can infer that this little height here is 2, and this height from the horizontal up to the top, that part would be 5, because the total is 10. And we're given some other information in the problem. We're told that the distance from the shorter post is going to be X units in length, and we're told that the total length is 10. So therefore I can infer that the length of this other side of the triangle, from the hanging traffic light to my tall post, must be 10 minus X. Now, I'm asked to find tension 1 and tension 2. So to think about this, I'm going to label some angles in here. I'm going to call this little angle here theta 1, and the angle on this bigger triangle here, I'll call that theta 2. So if I were to pull these triangles off to the side, that triangle over on the left there has a vertical side length of 2. We've got an angle here of theta 1, and this base is X. And similarly, this triangle over on the right, if I add the drawing, it's just a little bit easier to see if I pull the triangles off to the side here. We've got the vertical side there 5, and the base is 10 minus X. So what I know is if the traffic light is not being pulled to the left or pulled to the right, it's stationary horizontal, I know that the horizontal forces must be equal. So let's write that down. So the horizontal components of T1 and T2 must be equal. Otherwise, the traffic light would be moving to the left or moving to the right. So what that means is if I want to write the horizontal component of this vector T1, I would write T1, so the magnitude of T1 times cosine of theta 1. That better be equal to the magnitude of T2 times the cosine of theta 2. Now, we don't know what theta 1 and theta 2 are, but I could represent that. Let's see. I know that theta 1 I know that tangent of theta 1 equals opposite over adjacent equals 2 over x. In other words, theta 1 equals arctan of 2 over x. And similarly, if I come down here and work on what theta 2 would be, I can say that theta 2 equals arctan of 5 over 10x. So when I come into my equation that I had down here, I can say the magnitude of T2 cosine of theta 2, which is arctan of 5 over 10 minus x, minus, so I'll just move this puppy over to the other side, equal the magnitude of T1 times cosine of theta 1, which is arctan of 2 over x. So that must equal 0. And again, what we're working with here is this idea that the horizontal components of T1 and T2 must be equal, because the traffic light in the horizontal direction, those forces must be balanced. Now, we can also play this game in the vertical direction. So let's think about what's happening vertically. So in the vertical direction, so the vertical components of T1 plus T2, so the vertical components of the sum of T1 and T2 must be equal to 200 newtons, because we're given that that's how much the traffic light weighs. And the reason that is they must be equal is because if they were not equal, the thing would fall to the ground, or it would, fly up in the sky. So if something is stationary, it's not moving, we must have these forces that are balanced. So we can play this game again and think about what the vertical components would be. So for the vertical components, we are looking at the magnitude of T1 times sine of theta 1. And again, we don't know what theta 1 is, but we know that it's this arctan of 2 over x. So that plus the vertical component of T2. So again, we've got a sine of arctan of 5 over 10 minus x. Those things must sum to 200. And again, the reason for that is we're playing this game of the vertical component. So we've thought about what's going on horizontally. We've thought about what's going on vertically. And now what we have two equations. So that one, and we have an equation down here. We have two equations, and we can use those two equations to solve for our unknowns. Ultimately, we want to come up with the force or the tension T1 and also the tension T2.